Yep. We go on IR.
Yeah. All right, we can get started for Weather Watch, February 23rd. So I'll start with the long wave IR loop, as I have in the past. I want to first, there's a couple things. First, I'll point out the cold air in Canada because this is not going to last as we keep going into the spring and the summer. But you'll notice as this loop restarts, all of the cold air, as we've probably assumed, has stayed into Canada for the past week or two. It's trying to get down into our area as of recently, but you can see the loop. It's remaining around Hudson Bay. Nighttime comes, cools, and then the daytime heating takes over and it erodes a little bit. But you notice it doesn't really make it past the upper border of the United States. And that's been the feature of a couple of weeks now, it seems. Until, you'll notice at the very end here, here's our cold air for this weekend making its way down into our area. Doesn't appear that it makes it all the way to our area under the IR loop, but we'll see in the visible that this is actually, that lobe at the very end is making it into our state, and into northern Michigan and northern Minnesota as well. So cold air remaining in Canada. Then, let's see, we have to wait till it restarts here. I touched on there was a subtropical jet feature that had been sitting over Mexico. You'll see it right here. That's that same feature that sat for about 2 weeks or so. You can watch it just persistently, slowly move over into Florida and the Atlantic, bring a lot of precip into that region, but it still has only made its way into the Atlantic. So this is still a feature that's persistent. Now it's kind of stagnant. We'll see in the visible, it looks very beautiful, but it's not really moving. And it's only moved from Mexico into the Atlantic over this entire loop here. Then we had another so-called atmospheric river in the Los Angeles area. You'll see it up here with this system right here. Another one of these fire hose events right there. And it just persistently rained over the Los Angeles region, which does not need more rain. They've already gotten about a year's worth of precipitation over a couple weeks, and they got more from that atmospheric river. So that's another feature that we see on this loop here. And it's, I'll let it replay here, and it's interesting how thin that moisture stream was, you'll see. So it stems from this, and look at how thin that is. So a couple miles separates you from, 12 inches of rain and nothing. Pretty cool to see. Let's see what else I have. Oh, then once this restarts as well, the Labrador Sea and North Atlantic have been very stormy. I think that's pretty average for this time of year, but it's a very beautiful development right here. Nice cloud head. I'm sure there's a ton of precipitation happening into Greenland. Observations are, I didn't look into observations up there, but it persistently is snowing up in Greenland and raining through this entire loop, and I'll let it replay again for that gorgeous development. We got down to 948, that system that I'll point out here. So it stems from a little piece that moves along this, and then here's your system. And no doubt is influencing the cold air advection in its wake. Definitely not in our region, but over the Northeast as well. And then another thing to point out, we can watch over our region throughout this loop. We have had no precip for the past 7 days at the airport. So it's been dry for us, even though we've had some of these cloud features move over, but it's been nice and warm, temperatures in the 50s and 60s, which is very uncommon for this time of year. We've set a couple high temperature records and even low temperature maximum records over this period. And that will bring me to my next plot, if we could pull up the one I emailed. So Iowa State has a very cool website where you can make these plots of essentially a lot of different things that you want. But what this is showing, this is the average temperature rankings by climate district for essentially the winter up until yesterday. So one thing to point out, we're in the warmest winter in this period of record from 1983 to 2024. And it's not just our region right here, it's most of Minnesota, all of Wisconsin, and into Michigan here. Even regions, around are in the single digits for the warmest winter on record. And with 50s and 60s being forecast, I can only assume that we'll continue our warmest winter on record. So this is something that, we've heard about it. It's been 50s and 60s, very unnatural. We've had no snow cover for a while now. None that's been meaningful, at least, and you can see that reflected in the temperature ratings. It'll be interesting to see what happens, to the regions that are 2 and 3 if they make it into the warmest winter on record, or if they stay, in the periphery of setting records. But looks like for sure over our region and most of Wisconsin that will set the warmest winter on record based on this metric here. So that's something to note. It's been very warm, and it looks like it'll stay warm, and record-setting warm. And then if we could go to the current North America satellite loop, please. So we'll get a look at the current visible satellite for North America here. First, I want to draw your attention to South America. This is smoke from wildfires in the Amazon. Something that I saw this on the loop beginning to pop up and thought, here we go again, because that was our summer, essentially, was watching these smoke plumes move. But this is smoke from wildfires, and then as the sun moves across the Amazon, you can see it highlighted in the beginning right there. Amazon River, which is pretty interesting. Then here's that subtropical jet feature that moved from Mexico into the Atlantic, and you can see it spanning all the way into the deep tropics, all the way up into the mid-latitudes and close to Canada here. Here's our shot of cold air. We'll get a better look at it in a minute, but this is the cloud edge of the cold air moving south from Hudson Bay. You can see another system off the California coast. I'm not sure if when is that going to make landfall, but it looks definitely primed to make landfall here eventually. Most of the United States cloud-free, largely cloud-free, especially the central and western portions. You can see the snowpack in the mountains very nicely, but this is still February, and there's little to no snow cover over the contiguous United States, especially the lower terrain. I mean, this is all higher terrain that we can see. All the snow cover, it seems to go down to Canada and then stop, and the United States is completely snow-free. This is snow cover. Canada has a lot of trees, so what snow cover does is you're seeing the lakes and areas that are largely tree-free, but a majority of it is, the darker colors are the treetops that have melted, but the ground still has snow. So it kind of looks like, this is snow-free because you can see land, but this is snow cover. You can kind of see the white and the darker colors next to each other, and the lakes highlighted very nicely as frozen. And yeah, I think that's all I wanted to touch on here. And then we can go into what's happening over our region. So if we could pull up the 500 millibar map, please. We'll see sort of what's bringing our cloud cover.
You want the super feed?
Yeah, super feed, please.
Bad super feed.
No worries. So here's a look at the 500 millibar map from this morning, 7 a.m. So we're situated in the downstream of a little bit of a shortwave trough. You can definitely see it in the temperatures. We have a lobe of cold temperatures that is stemming from Hudson Bay down. You can see it sort of, this were a loop, you'd see it swinging down towards our region. We're largely in a region of little to no temperature advection at 500, but the cold air and the cold air advection at 500 is well to our north. But it's still pretty cold for our region, and we have this shortwave trough, which downstream would lead to a little lift over our region. And so that's important to note. In its wake, you have a nice ridge developing over where we saw it being largely cloud-free over the western United States. Here's that system that was sitting off the California coast. Looks to be two maybe low-pressure systems, unclear, based on the visible satellite loop that I showed. We couldn't really investigate that as much. And then here's some semblance of your subtropical jet. I won't go into much more details, but that's largely where it was located. But so we have this shortwave feature. Cold air advection well to our north, but still pretty cold over our region. And then if we could go to 850 now. So here's where it gets more interesting. Now we see a pretty clear temperature distribution. Here's your cold air. You can see winds straight from the north, pretty strong cold air advection. This still, as 7 a.m., was to the north of us, but we'll see in the satellite it's encroaching ever so slowly to our region. Very strong cold air advection in, this is Quebec, Canada, and into the northeast, and we'll see that in the surface obs. But this is largely, very cold air, minus 21, flowing into -1 air, so pretty strong cold air advection. Not unnatural for this time of year, but it's definitely something to note as it has been warm as of late. So we'll see this sort of cold air advection reflected in the cloud cover when we go to the visible, and then in its wake, you can see temperatures are very warm all the way up into central and north central Canada. So here's our cold front, essentially, as reflected in the 850 temperatures. Now can we go to the surface, please? And we'll take a look at what's happening at the surface. Here's the extra piece to what we need for our cloud cover and maybe some snow. So you can see here's Madison, 41 over 28 with a westerly wind. And just to our north, and we can maybe look at a closer look at the state, but we have northerly flow, temperatures in the 20s. So that's a pretty good temperature difference, 15 degrees over from our region to Wausau. And look at the 90-degree wind difference is also of note. It's beginning to snow up in Wausau, and we'll see that, maybe some resemblance of that in the visible satellite loop. But here's your cold front at the surface. So this is largely a surface-based feature where we have a sharp temperature difference, we have strong cold air advection, but we don't really have too strong of an upper level feature forcing this potential for snow, it seems. And you can see temperatures where it hasn't been cloudier in the 50s, just where we are in the 40s. I can imagine, Kenosha or Racine might be in the 50s as well. So here's our, a different feature for our cold air, and this flow is coming all the way from Hudson Bay straight down, producing some lake effect snow. Over Superior, the lakes are completely ice-free, so any cold air moving over it is going to produce clouds and precipitation if it's strong enough. And then back where I showed the very strong cold air advection into Quebec, look at this temperature difference, 36 to 6 degrees. That's 30 degrees difference in the wind shift. And I mean, let's say you're driving, I don't know where this is, but you're at this station, you're driving west, you go from 36 to 0 degrees. Not a lot of real estate you're covering as well. So 2 areas of pretty strong cold air advection, one into Quebec and then one over our state as well. And then the dew points are falling also close to below 0 into the northern portion of our state, and then in Michigan, 2 degrees dew point. So interesting that it's still producing snow, though. You have a pretty good dew point depression with this system as well. Then if we could go back to the visible, and could we go to the goes east images and loops? Go back. And then we'll go to the Wisconsin area and the 3-hour loop. It was very hard to see on the large scale, visible satellite loop, but here's the area of weather for our region today. So first, here's this cloud feature that's moving from the northwest, bringing some slight precipitation. This is not our cold front. This is a separate feature that developed and is just strong enough to produce light precipitation over our region. Here's your cold front you can make out moving from the northeast down. So portions of Green Bay into Green Bay, and then towards the northeast are colder than portions of the northwest to our northwest. With this cold front, and then its wake, you can see all the lake effect cloud streaks. Very obvious feature that we haven't really seen most of this winter because we just haven't had cold air moving over our region. But here's some of the lake effect snow as it moves on shore. Friction can take over and produce a little more lift, and you have mountains up into the UP. So definite snowfall up in the UP, and then some potential for snowfall along this very thin, cold front that's moving over our region as well. It's interesting that the lakes are not frozen over, so it might be an interesting question of what would this have looked like if we had ice cover. Would it be colder? Did the lakes modify this as well? Would we have even gotten snow cover because we wouldn't have as much moisture coming off the lake? Interesting question. I don't know the answer.
Yeah, one thing you can see in this image too is the thermal wind. You can't miss it because the
That's right.
winds at the lower levels are from the northeast over Lake Superior, and then you got westerly winds aloft.
Yep.
It's strong cold advection.
That's right.
Unmistakable.
That's right. So it seems like most of the action for today in this cold front is focused right on Wisconsin. So in the morning, Pete showed this loop earlier. It was a gorgeous morning. It was 40 degrees and sunny. And if you didn't check the weather, you'd think, oh great, we're gonna have another 50-degree day. It's gonna be beautiful. Then all of a sudden, nope, we have 40 degrees and snow coming for us later. So,
Super cool gravity waves too. There's some over here early on,
oh yeah, you can see.
and then there's a bunch right along Lake Michigan.
Right,
Looks like
yeah.
almost a lake breeze today too.
Yeah, lake breeze, that's right. We had one of these when, I think it was Thursday maybe. We had our first lake breeze of the season in February, which usually happens in July and August. That's how warm it's been over our region. And that's all I had. Is there anything anybody else wants to talk about or questions? Something like that?
Show the same thing with the day cloud phase. The reds and the yellows are higher, the kind of magenta, or the cyan color is lower.
Lower. Yeah, so it looks like a lot of low clouds over our region. Okay.
Okay.
Thank you.
Thanks, Patrick.
Well, Patrick, thank you for showing some interesting things again every week you do. I'm holding off. Big news coming next Friday. But I don't have a good feeling about it. I'm just going to level with you. We had 4 days in a row where we made up ground against number one, 2014-15. Then we had 2 days where we lost ground, rather substantial ground. I think over the course of the week, since I last announced about the cold pool, we probably cut the deficit a little bit, but I don't know what to expect. And I could have used forecast information to kind of get a peek ahead. I didn't want to do that. I feel like it's, it's like hoping for your team to make the playoffs. I'm just going to keep on the fence all week long. It's going to be exciting. We're going to come close. We'll definitely be the number 2. There's no question about that if we don't get number 1. And that's pretty unbelievable. And Patrick, the regional reflection this year is very different from the regional reflection of 14-15 when we had some of the coldest air in the wintertime that we've ever had even, in the same year that the hemisphere was warmer. So this year, North America seems to be in sync with what's going on in the hemisphere. That wasn't true in the current record year. So that in itself is an interesting thing to examine at another time. Let's do a quick look at the forecast. I haven't had any time to think about it. Probably half or more of you could say more than I could today. It's just been one of those weeks. Yeah, that'll work fine. Let's take a look at the 500 millibar map at 12 hours in. Actually, let's go to the 0 hour forecast. This is the thing that caught me by surprise today, was that, Patrick mentioned when looking at the 500 millibar map, there was this little wave, broad scale wave over the whole part of eastern Canada. But it's this little feature right here that actually showed up in the odds rather dramatically as well. That's probably the feature of interest coincident with the passage of the cold front that might make the afternoon a little more interesting than many of us bargained for. Some probably knew was coming. I wasn't paying attention. But I think that the rapid southward advection of this, in addition to the cold front at the lower troposphere enhancing convergence as it comes through, might be enough to give us something of considerable interest later today. So that's interesting.
So we have the snow squall warnings go off at the
Well,
solstice party.
as we all know, 2 years ago, it
That
was
was
rather
crazy.
dramatic,
Yeah.
and everybody played their role, went to the window and didn't talk to each other. So that was really pretty cool. I don't think we're going to see quite the same thing today, now, partly because the ground is so dry. I mean, one of the things for snow squalls that you need pre-existing water available somewhere in the ground. We just didn't have that. Well, we don't today. So all of this will be generated by updrafts and condensation of available water vapor in the atmosphere, no liquid water on the ground. So that's a little different. So what we'll do quickly is look at the evolution of this feature. This is the boundary for the really superlatively cold air that may infiltrate here this weekend. But as you can see, the boundary also has a western edge and that western edge is almost at our longitude. So this whole wave progressing will bring that western edge through us rather quickly. So the early part of the week coming after the weekend is rather interesting as well, so we'll pay attention to that. So let's go to 12 hours into the forecast here, Pete, keeping in mind that we started right there with our wave, and look at by tonight, it's in the northern part of the state, arguably split up, but it's making rapid progress southward at the same time the cold air is. So that's why I think maybe a coincidence of these two features later this afternoon might be the reason why the forecast panels have this forecasted precipitation. It seemingly comes out of nowhere in the middle of a surface anticyclone. It's not coming out of nowhere. It's tied partly, I think, to this upper wave and partly to surface convergence at the cold front. So that's interesting. Okay, then one more 12-hour period. So we started here and we ended up in the northern part of the state. Let's see what happens by the end of the day. Yeah, by the end of this period into early tomorrow morning, that wave has made its way all the way into, southern Illinois, Tennessee. So that's a rapid progression southward from, just south of Hudson Bay to here in 24 hours. Very rapid in the northwesterly flow. Okay, so the threat of precipitation ends easily by tomorrow morning. We're downstream of the ridge axis, so there'll be upper convergence, and surely there'll be a clearing out of this snow squall if it comes by. It'll be late this afternoon. I don't think it'll impact any of our festivities tonight, like the one 2 years ago didn't. I mean, that was amazing that it didn't actually, because it was really heavy, but it didn't last long, and it came after everybody had gathered. I think some of those same characteristics will be true today, so that's good. Let's look at 850 millibars, though, at the same time. So first the 0 hour, and that'll be mostly where the concentration is for the rest of my discussion. So at 850 this morning at 12Z, there's the 850 front, and at the surface, it's almost on us. And in fact, by the time we got out of class today, we saw melted rain and a little bit of maybe some graupel, some kind of mushy snowflakes, and that's probably just the beginning of the story. Looks like really strong cold advection, but again, here's the western edge of that first dollop of cold air. And on the far western edge, there's lee-side warming in the lee of the Canadian Rockies, as well as the northern plains of the United States. So that puts a really sharp boundary to that cold air and contains it fairly well. So let's go to 12 hours into the forecast, Pete. So this will be tonight. The major portion of the cold air, not surprisingly, is headed to our east. Here's that western boundary, and it's nearly at our longitude. We get colder by tonight, there's no doubt. I mean, it's going to be a decreasing temperature all day long today, and there'll still be cold advection at 7 p.m., although it's fairly modest. So we'll end up with a rather chillier night than we've had most of the week, this week. No doubt about that. But I think any of the surface convergence, and perhaps, as we saw, the 500 millibar vortex is kind of right about here, we might see some snow flurries or maybe the end of a snow squall by about 7 p.m. over us. There's enough evidence to be at least on alert for that. But this lee-side warming continues even though it's midnight, and so that's going to be pretty strong warming, and that'll have an impact on what comes next. So let's go to...
That's actually 6 p.m. our time, not quite midnight.
Oh yeah, not midnight. I was thinking at nighttime. I meant nighttime.
Late afternoon.
So let's go about 12 hours ahead to Saturday morning. And then you see we're setting ourselves up for some pretty strong warm advection over the central plains, the Dakotas, Nebraska, Kansas. Look at that gradient of temperature. It's on the order of 10 or 15 degrees over a fairly short distance. Very strong westerly winds there. We are as cold as we're going to get probably overnight, and not even by 12Z tomorrow. It might already be on the warming trend by then, but perhaps that's just about the minimum temperature. And then it's going to be a substantial warm-up, it looks like. With all generated in conjunction with a cyclone in the western shore of Hudson Bay near Churchill and the lee-side warming. And all of that combined, especially at lower latitude, the lee-side warming gives us a chance for a fairly rapid recovery after a cool down tonight and into tomorrow morning. So one more time, let's go 12 hours ahead. So we go to Saturday night. And by then, man, look at this. This is a robust warm tongue further to the south now. It's still got a lee-side component though, because look at the geopotential height. It's coincident with the warmest air. So that's a really robust lee-side trough, getting stronger in the southern plains instead of the northern plains, and strong warm advection by by the evening on Saturday. So it's a really quick cool down and then a fairly rapid response. It does look like we have more cold air in store, but it's fairly remote, but nonetheless, one keeps an eye on that. And let's just keep going at 850. That's going to be the bulk of what I say, I think. Every 12 hours or so would be great. So by the time we get to Sunday morning, this is totally different air than the pink, which is it's on the order of 18 degrees warmer at 8:50 by Sunday morning than it was on Saturday morning. That's really nice. So 25th of February, this is dollop of cold air. The -5 isotherm is the first of the light blue, so it's about this one right here. So climatologically, that is probably about where it usually is about in this part of the hemisphere. I don't know what it's doing in the rest of the hemisphere. So this little cool spot over the northeast United States is probably contributing to an anomalously colder spot, but I don't know if there's any other ones. And we're 3 days from the end of the mission. In fact, don't forget when I tell you on Friday, I'm not cheating, I'll tell you that right now. I only use February 1 through 28, I don't count weekdays. So, if it looks like I'm trying to cheat, that's not the case. That's the whole record, that's only up to February 28th, so don't be saying things about me behind my back. Okay, let's go at 12 hours ahead, this will be Sunday night. And then, yeah, it does look like there's a chance for yet another cold wave to make its way here, but we're still at the same temperature we were on Sunday morning by the time we get to Sunday night. It's not so bad. I think we're going to see, again, a lee side warming. In fact, at this time, let's go to 500 millivolts, 60 hours in. 500 because it's about mountain height. Constant westerly winds. Okay, so there's little troughlets embedded within this broad upper trough over Canada, but the westerly wind over the Rocky Mountains ensures that it stays warm right here. And to the extent that that is upstream of Wisconsin, and we have this tendency for troughiness anyway, like this feature here might come in and dig a little bit of a trough, produce a deep southwesterly flow over us a day or two downstream, that's going to take advantage of accumulated lee side warmth and drag it over us. And I think that's what happens by into the day Tuesday. Here we are only on Sunday night. So that gives you a quick update on where we are at 500 millibars, but I see that westerly flow, and I think that's going to be warmer than normal for us. It always is in the wintertime. And so let's go to 12 hours ahead at 8:50. And son of a gun, look at that warm bubble that's starting to develop here. The warm axis goes all the way from central Texas up to northeastern Montana, and that's just about coincident with, at this point anyway, a fairly flat geopotential height trough, but nonetheless a trough. So that's a long, continent-wide lee side trough, unsurprising given what we saw at 500 millibars and the presence of the mountains. Look at the warm advection that ensues on the northeast side of this thing. This is in Des Moines. You've got a really strong wind across the central part of the state of Iowa, and temperatures in the blue are 20 degrees C at 8:50. So this is really warm for early Monday morning in southeast Iowa and southwest Iowa and parts of southern Nebraska. And we are in position for some strong warm advection during the day Monday. Let's see what we get by Monday night. Oh boy, greens and yellows. We like greens and yellows because that's anywhere from about 8 to maybe 14 degrees C when you get to the yellow. So we're well above zero at 8:50. There's still a clear evidence, even at 6 p.m., of a lee side trough. So that's being fostered by the westerly winds over the high terrain. It's not being abandoned and cooled off at night. It's being fostered. And so warmer and strong warm advection, the troughiness ensues because of the subsidence as well as warming it up. So everything works together to produce warm advection to the northeast, and we are the recipients of it. So this is Monday night. We got to see Tuesday 12Z. Look at that. The bubble moves a little bit further to the east, the whole trough does, but we're still receiving warm advection by early Tuesday morning. This yellow right here is 14 degrees at 8:50. So you add, what do you add? Maybe 6 degrees for a kilometer and a half or something like that, and that's being conservative. So we're in the mid-60s on Tuesday. And I don't think it's impossible to make a run at 70. I really don't. And I don't know this. I don't know if we've ever had 70 or higher in February. Maybe somebody knows that off the top of their head. I don't. I should have looked that up. But it's going to be exceptionally and ridiculously warm on Tuesday, it looks like here. But there's a looming threat to the northwest. So the early part of the week, we get cold tonight into tomorrow. Tomorrow won't be such a warm day, but there'll be warm advection during the day tomorrow. And then by Sunday, it kind of recovers a little bit. And that recovery is accelerated through Monday and Tuesday. Peaking at Tuesday, we're going to have a really warm day here on Tuesday. It's going to be almost unbelievably warm. But this baroclinic zone to the north and west through Minnesota and into western Nebraska is intense, and it's going to get more intense. So let's take a look at, I guess we'll keep going at 12 hours, Pete. Look at how sharp that baroclinic zone gets. There's an invasion of cold air into the central plains, no longer any lee side troughing. And this is a really sharp baroclinic zone. So we're a little bit cooler by the time we get to Tuesday night. I was telling my class today, if you're interested, you might want to hang around outside during the night on Tuesday, because you will feel a cold front come by. And we haven't talked about it in class yet, but you'll feel it, and you'll know what we're talking about in one extreme case. Another thing to do if you're interested in such things, start paying attention to the time series in Oklahoma. The Oklahoma mesonet will be interesting on Wednesday and Thursday, because this thing will make its way southward, and temperatures will drop 30 or 40 degrees in 5 minutes in some of those locations. I wish they had one in Kansas for this event, because this is going to be a sharp passage through the state of Kansas as well. So this is Tuesday night. Let's go just 6 hours. Let's go to midnight on Tuesday. Remember, the cold front's a little to our west at that prior time. It is just about at 8:50 through us by midnight, so I think at the surface it'll be through us between 9 and 10 p.m. would be my guess. So if you're up Tuesday night at 9 o'clock, you want to find yourself in an open field looking to the north and experience what that's like, because that's pretty dramatic. Here's where the mesonet in Oklahoma starts to light up too, is around midnight or so on Tuesday night. So that's the end of the warmth. We get really warm Tuesday, and then we get chilly. Let's go a day ahead into like midnight on Thursday. Is that a midnight on Thursday? That's a rapid
Midnight
transition.
Wednesday, I'm sorry.
Okay.
Is that right?
I think you were right, Pete.
Did I have the right one?
Yeah. We're going to have to not go 24 hours. We have to see how this evolves. Let's go just 6 hours.
So that's midnight on,
Yeah, 114 hours, so let's look at 120. And cyclone developing along this front. It's not an intense cyclone. I don't think the structure is right to really get that well developed, but the baroclinic zone is intense, and so the sensible weather delivery is really remarkable. It's going to get much, much colder very rapidly. This is Wednesday morning, so we just had 68 degrees for a high on Tuesday, and we're going to be back into the 30s the next day. It's going to be really rock and roll. And so this is the last day for accumulation of the cold pool too, so no matter what happens, people are going to say, what, warmest winter? What about yesterday? And that's about how it goes. What have you done for
What
me?
about yesterday?
That's how everybody goes.
The southern half of this also seems like it's a severe weather setup.
That's probably right. I
Yeah.
don't know much about that, but a strong cold front doesn't hurt.
And the southerly flow from the Gulf of Mexico is
Yeah.
sitting there for 3 days.
Very good point.
I would not expect, I would definitely expect tornadoes in like Arkansas, Texas, probably. I think,
Let's take a look at the surface forecast at this time, because this could be interesting. Could be
Yeah.
a pretty good day there.
Yeah.
Wrong time of day maybe. That's a band of forecasted precipitation along the cold front, a fairly intense cyclone, 985, really strong cold advection behind it. How about 6 hours ahead, so we're at midday?
ahead or before?
Further downstream in time, I mean. It lights up a little bit, doesn't it?
Yeah.
Ohio River Valley. So I wonder if that's, and let's look at 500 millibars. This will be, we don't know if this is convective, but there's a trick.
yeah, it could be.
Yeah, it's convective because there's negative absolute vorticity. How does that get there? Convectively unstable air lifted to 500 millibars. Moist PV's negative down there, has to stay negative. It stays negative in a stable environment because the vorticity goes negative. So you can always use tricks to figure this stuff out. Look at the sharp upper vortex there. That's the 500 millibar intersection of this cold front. So this is a deep, very intense structure, and right on its surface edge, there is, it looks like a linear band of convective severe weather. So that's really interesting, and widespread. Some of these might be related to the ascent there too, but this is probably right along the cold front ascent. So it will be an interesting day in the south on
Yeah.
Wednesday, that's for sure. So that's it. We have, as I said, a cooling down all day today into tomorrow night, tomorrow morning, and then a gradual warm up that's accelerated Monday and Tuesday, and with a peak. I don't know if it won't be 70 on Tuesday. I don't know. It's possible. But it won't stay 70. It's going to be in the 30s on Wednesday, and then it'll be interesting to be looking south of us on Wednesday as well. Be some interesting weather down there. So that's all I have. Thank you, Pete, and thank you, Patrick, and another excellent discussion as usual. And I'll see you all next week.
Or that cutoff just died. That cutoff that's kind of spinning on there.
Oh, yeah,
It's just
yeah.
crap out.
Yeah, there used to be one, they used to say that was one of the worst problems.
Yeah.
What happens
Oh,
to
yeah.
these things, how do they get rejoined?
And when that thing
Yeah.
comes in, might have something to do with the likelihood of severe weather on Tuesday and Wednesday.
I wouldn't doubt, it comes, sweeps across the plateau.
Yeah, and then you get the
Elevated
upper
mix
level,
right,
Yeah,
yeah.
the mid-level dryer coming off the.
Yeah, I hadn't thought of that, Andre, that's right on target, that's gonna be a pretty
Yeah.
wild day down there.
Look at
And
that
it's
thing.
this setup where you get, it's like this midwinter setup that is when you get the severe weather outbreaks in winter time.
Oh, yeah, and that's why it's a late winter, early spring